I was probably Denny's best dishwasher.
In a dimly lit corner of a Denny's, three men huddled over a greasy table. The air was thick with the smell of sizzling bacon and coffee, while their thoughts circled around a depleting bank account while unemployed. Around this time was right when the PC revolution was getting started, with the introduction of Windows 95, which was groundbreaking for Windows. At that worn-out table in Denny's, Jensen Huang, the visionary, scribbled across diner napkins the concept of what would become a technological titan. The co-founders thought, let's believe and build a company to solve problems that normal computers can't. And that became Nvidia's mission. How does a group of first-time founders pitch their idea and gather investors? Jensen did what most people would start with, reading how-to articles. But the problem was that Jensen and his family only had 6 months of finances left. So instead, his former boss, Wilf Corrigan, reached out to Jensen to know why the heck he left the company, and that's when Jensen pitched his idea. By the end of it, Wilf said, "I have no idea what you said. That was one of the worst elevator pitches I've ever heard." Wilf then called the renowned venture capitalist Don Valentine. As the founder of Sequoia Capital, Valentine had made early investments in companies like Apple, Atari, and Wilf's LSI Logic. And Jensen was nervous on his second try of a pitch. "Well, that wasn't very good," Valentine said. "But Wilf says to give you money, so against my better judgment, I'm going to give you money." With funding from Sequoia, Jensen and his co-founders, Curtis and Chris, started Nvidia. Initially, a company focused on creating GPUs, or graphics processing units, to improve the quality of video game graphics. 3D graphics technology was impossible to make cheap, and at the time, the video game market didn't exist. The founding of Nvidia was to bridge the gap between the astronomical cost of 3D graphics and bring it to video games. Jensen reflected on his reputation that led to this first step.
But you can't run away from your past. And so have a good past.
For a decade, the markets that fuel Nvidia today were barely starting. That's a really long time to try to keep innovating and solving new problems without people knowing and buying the technology. 6 years later, Nvidia launched GeForce 256, the world's first ever GPU. The crowd goes wild. Nvidia achieved what it originally was founded to do: make 3D stuff on computers look amazing. The intended audience were game developers, which they quickly embraced in order to create more visually complex and immersive games. Then, leading PC manufacturers also saw the brilliance of Nvidia GPUs, like Dell and HP. The next big step was when Nvidia established original equipment manufacturer, or OEM, partnerships with companies, which meant they integrated Nvidia GPUs into a wide range of devices beyond just gaming PCs, like workstations used in design and engineering fields. In addition to GPUs, Nvidia introduced CUDA, or Compute Unified Device Architecture, a parallel computing platform and programming model. CUDA allowed developers to use Nvidia GPUs for general-purpose processing, which significantly boosted the performance of scientific and engineering applications. Said in a different way, computer brains work together equals solving big problems really fast. In the early 2010s, the field of deep learning was rapidly evolving, but one of the major bottlenecks was the time and computational power needed to train neural networks. Traditional CPUs were not well suited for the parallel processing demands of neural network training. Researchers observed over 100 times speed up in training times when using GPUs instead of CPUs. This drastic improvement meant that complex models could be trained in a matter of days rather than weeks or months, which accelerated research and development in AI. In 2012, AI was a niche field with limited commercial applications and virtually no market size, which sounds like when Nvidia started in the gaming industry. Despite this, Nvidia decided to invest heavily in AI, seeing the potential for GPUs to revolutionize the field. Nvidia started to focus on developing GPUs and software frameworks tailored for AI and deep learning. Alex Krzyzewski, a student of Geoffrey Hinton at the University of Toronto, along with Ilya Sutskever and Hinton himself, created a deep neural network called AlexNet. This groundbreaking model was designed to use the incredible parallel processing power of Nvidia GPUs. By training AlexNet on just 2 Nvidia GTX 580 GPUs, they drastically cut down the training time and could experiment with much larger and complex models. This was key to their success, allowing them to build a model that outperformed everything else at the time. AlexNet entered and won the 2012 ImageNet competition with an astounding error rate of only 15.3%, while the second place model had a 26.2% error rate. This victory was more than just a win. It was a clear demonstration of how GPUs could revolutionize AI research by making deep learning much faster and more efficient. The success of AlexNet was a game changer for the AI community. It showed everyone the practical benefits of using GPUs for deep learning, leading to a massive wave of interest and investment in AI. After AlexNet, Nvidia GPUs became the gold standard for training deep learning models. Companies and research institutions all over the world started using Nvidia GPUs, fueling rapid advancements in AI. So when OpenAI credited Nvidia's GPUs for enabling their research this whole time, particularly towards training ChatGPT, pretty much everyone started rooting for Nvidia. OpenAI, founded in December 2015, required powerful computational resources to train its machine learning models. Nvidia, a leader in GPU technology, provided the hardware necessary for these intensive computations. For instance, in training large language models like GPT-2 and GPT-3, OpenAI leveraged the computational power of thousands of Nvidia GPUs to achieve breakthroughs in natural language processing. In the earlier years, Nvidia stayed under the radar. It was when Bitcoin mining started ramping up, then Nvidia's GPUs were really popular for mining Bitcoin and Ethereum. This boom increased Nvidia's sales, causing the stock price to rise. Around 2016 is when you can really see Nvidia's market cap aggressively increasing. Then, the 2018 Bitcoin crash led to a fall in Nvidia's stock price. The pandemic saw a huge rise in demand for Nvidia's GPUs, supported by remote work, gaming, and COVID-19 research, raising its profile and stock value. At this point, Nvidia crossed over Intel at $300 billion in market cap. Nvidia slumped in 2022 due to rising inflation and interest rates, supply chain issues, and geopolitical tensions such as Russia's invasion of Ukraine. The believers didn't stop there and easily rebounded. The release of OpenAI's ChatGPT and AI boom boosted Nvidia, as its GPUs, essential for AI model training, saw increased demand. This, coupled with Nvidia's lead in AI and machine learning, sparked investor confidence, enhancing its stock value. Today, Nvidia's market cap is at $3 trillion. They soared into the top 3 companies in the world with that metric, right next up to Microsoft and Apple, jumping over Google. Is Nvidia overhyped? Or do they perhaps still have room to grow? Let me know in the comments what you think. For such a large impact company and only 30,000 employees, this has been a long and great journey for Jensen Huang and his team. Nvidia continues to innovate in AI hardware and software. They are developing more advanced GPUs and AI platforms, such as the DGX systems, and software frameworks like Nvidia Triton Inference Server, which support the deployment and scaling of AI applications like ChatGPT. All eyes are on Nvidia now, and it'll be really interesting to see how they keep innovating from here. Thanks for visiting Too Big to Frog. We'll see you next time.